So we take a few minutes now to describe how we handle exponentiating complex numbers. And the definition that we're going to start with is the following. We know that I is equal to the square root of -1. So knowing that, let's take a look at what would happen if we squared I. Okay, so off to the side over here, well, we'll put it underneath. Okay, so if I is equal to the square root of -1, then I squared is going to be the square root of -1 squared. And notice what happens if we have the square root of something squared, we can cancel those guys out, and it's just equal to -1. So isn't that interesting? Here we have an example of a number when we square it, of a value when we square it that will give us a negative. Again, this doesn't happen in the real number system, but this does happen in the complex number system. Okay, so I'm going to write this off to the side, and we're going to prove some other values as well. We know by definition that I is equal to the square root of -1, and we just show that I squared is equal to -1. Well, let's take a look at what happens if we have I cubed. Okay, so I cubed. Well, I cubed, by properties of exponents, we can rewrite that as I squared times I to the first. Well, what do we know about I squared? We know that I squared is equal to -1. So this is the same thing as saying -1 times I, which is the same thing as saying -I. So anytime we see I cubed, we can replace that down to -I. Interesting. All right, so let's take a look at some other examples if we have I to the fourth. Well, here's a neat one. I to the fourth is equivalent to saying I squared times I squared. Again, when the base is the same and you're multiplying, you add exponents, and 2 plus 2 gives you 4. As we said before, anytime we see I squared, we know that that's the same thing as saying -1 from this guy right here. So we can rewrite this as -1 times -1, which is the same thing as saying 1. Okay, so continuing down this path over here, I to the fourth is equal to 1. Okay, interesting. So here's what we know. We know I squared is the square root of -1. I squared is equal to -1. I cubed equals -I. I to the fourth is equal to 1. Let's try a few more of these and see if we can build up a pattern here. Well, I to the fifth. I to the fifth is equivalent to saying I to the fourth times I. And that's equivalent to saying, well, we know I to the fourth is equal to 1. So it's 1 times I, or I. So I to the fifth is the same thing as saying just plain I. Okay, let's do a few more. I to the sixth is I to the fourth times I squared. And we know I to the fourth is equal to 1. And we know I squared is equal to -1. So 1 times -1 is equal to -1. So I to the sixth is equal to -1. Now, what I'd like for you to do now is really start focusing on a pattern that we see as we build up these. Let's do 2 more. I to the seventh, that's the same thing as saying I to the fourth times I cubed. We know I to the fourth is 1. We know I cubed is -I, and over here. And that's equivalent to saying 1 times -I, which is -I. So I to the seventh is -I. And let's finish this proof here with I to the eighth. I to the eighth is I to the fourth times I to the fourth. That's the same thing as saying 1 times 1, which is 1. So I to the eighth is equal to 1. Now, the pattern that we build up here, we're going to talk about in a second. The 2 definitions you really have to make sure that you're comfortable with are these first 2, because we can develop everything else from them. So keep in mind, anytime we see I, that's equivalent to saying the square root of -1. And anytime we see I squared, that's the same thing as saying -1. So in terms of what we see here, do you see this pattern that I to the fourth and I to the eighth are the same? That I to the seventh and I cubed are the same. They're both equal to -I. That I to the sixth and I squared are the same. And also that I to the fifth and I to the first are the same as well, where I to the fifth is the same thing as saying I. And this is no mistake. These factors of I will always reduce in this manner. And ideally what we're doing is we're looking for, now remember, one of the big proofs that we use here is I to the fourth. Anytime we have a multiple of 4 in the exponent's position, we know it's going to reduce down to 1. So I to the fourth was 1. I to the eighth was 1. If we were to continue with that trend, I to the 12th is equal to 1. I to the 16th would equal to 1. So if we want to reduce large powers of I, let's use that as our proof to help us. Let's take a look at these two examples. So example 1, I want you to express I to the 23rd as a complex number. Okay, so I to the 23rd. Here's how we're going to prove it. We're going to look for the biggest multiple of 4 that's in this exponent of 23. And the biggest multiple of 4 that's less than 23 is 20. And then we're going to have 3 left over. Now, the reason we're looking for that biggest multiple of 4, I to the 20th, is we know that anytime we have a multiple of 4, we're going to get 1. So this is the same thing as saying 1 times. And I cubed, as we look over here, that's the same thing as saying negative I. So 1 times negative I is negative I. And if we were to express this as a complex number, it's the same thing as saying 0 plus, 0 minus 1i. There's no real part to this. We have an imaginary part to this, and the coefficient of that is negative 1. Let's try one more. Let's express I to the 37th as a complex number as well. Well, I to the 37th, when we reduce this, we're going to look for the biggest multiple of 4 that's less than 37. So I can reduce this I to the 36 times I to the 1st. That's equivalent to saying 1 times I, and that's the same thing as saying just 1i. As a complex number, we would call this 0 plus 1i. Let's just do one more example just for fun. Let's say I am looking at something like I to the 42nd power. Okay, well, I to the 42nd power, the biggest multiple of 4 that's less than 42 is 40. So we have I to the 40 times I squared. We have 2 factors of I left over. I to the 40 is the same thing as saying 1. I squared is the same thing as saying negative 1. So this number, I to the 42nd power, is actually equal to the real number negative 1. And if we were to write this as a complex number, we would call this negative 1 plus 0i.